right, you guys, we are on slide 12, relationships among inscribed angles, radii, and chords. All right, so let's see here. So we have a GeoGebra, so let me open that up. Okay, we've got a blank GeoGebra again, so it looks like we're going to be creating a circle. Okay, so it says draw a circle with center A and a radius of your choice. Create 3 well-spaced points B, C, and D on the circle clockwise, alphabetical order. All right, let me draw a circle first. I'm going to come over to the circle icon, select circle with radius. Again, I'm going to do myself easy. So let me do what I did before. I'm going to do a radius of 4. All right, so let me read this one more time. It says to create 3 well-spaced points B, C, and D on the circle clockwise, alphabetical order. All right, so I'm going to click on point. So let's see, there's me a B, C, D, and there they are, clockwise, alphabetical order. All right, draw 2 radii, AB and AC. So I'm going to come over here to segment, connect A to B, connect A to C. Those are chords, by the way. I'm sorry, they're not chords. Those are both a radius, by the way. All right, now draw 2 chords. I'm going to draw a chord DB, D to B, and the other one is D to C. Yeah, those are chords. All right. Okay, measure and record angle A, because that's the letter in the middle, so angle CAB. And angle CDB. That's the angle D because that's the letter in the middle. So CAB. So come over here to your angle icon and select angle. And since I'm looking for angle A right here, I got to go in a clockwise motion. So I'm going to click on A first. I'm sorry, that's a C. Click on C first, then A, then B. All right, let me move that out so you guys can see it. I got 103.7. Oh, I know where they're going with this. Okay. Now I got to find angle D, CDB. So I'm over here to angle. Click on C, D, B. All right, and that's 51.85. All right, so let's see. I got to record those. So let me put this in. So angle CAB, that was 103.7. All right, an angle CDB, that is 51.85. All right. Take a screenshot of your diagram with the measurements and paste it below. All right, so I bet in the next question they're going to ask me what the relationship between this is. So I know where they're going. I know what the answer is already. So let me put this in. All right, let's submit. All right, question number 2. Compare angle A and angle D from question 1. How are the measures of the 2 angles related? All right, so when I said I know where they're going with this, this is what I meant. This is what we call a central angle, angle CAB, because its vertex is at the center of the circle. So angle BAC or CAB, however you want to call it, A is the letter in the middle. That's a central angle. Angle CDB, or if you want to call it BDC, it's fine, as long as you put D in the middle. That's what we call an inscribed angle. An inscribed angle is always half of a central angle. So if you don't believe me, you can take whatever your central angle is, divide it by 2, and that will be your inscribed angle. 103.7 divided by 2 is 51.85. So that's the relationship. Angle CDB is half of angle CAB. Let me put it because 103.7 divided by 2 is going to be my, what was it, 51? 51.85 equals 51.85. question 3. Now change the central angle CAB and see how it affects the inscribed angle CDB. To do this, move point B around the circle without crossing points C and D, and do the same for point C without crossing B or D. All right, record 5 data sets. Okay, well, it's not going to change. Nothing's going to change because an inscribed angle is always half. But I'm going to do what they said. So they said to move B. Let me move it over here. Let me move it right there. All right, so let's see. I got 172.52. So if I divide that by 2, I get 86.26. All right, let me do something else. Let me make it really small. Let me make it small. All right, so I got 52.29. If I divide that by 2, I get 26.14. All right. How about 74.27? If I divide that by 2, I get 37.13. All right. All right, I got 222.61. If I divide that by 2, I get 111.3. All right, last one. All right, central angle 73.65. If I divide that by 2, I get 36.82. All right, let me submit that as question number 3. All right, question number 4. Did you reach the same conclusion in both question 2 and 3 based on your work so far? What can you conclude about the measure of the central angle and the inscribed angle that intercepts the same? Well, one more time. They are going to be the exact same. I'm sorry. They're not going to be the exact same. You're going to take the central angle and divide by 2 to get the inscribed angle. So, let's see. The central angle divided by 2 is the inscribed angle. All right. Okay, good. Same thing as when they say half. Question number 5. All right, you've already moved points B and C on circle A. Now try moving point D on the circle without crossing C and B. What do you notice about the central angle and the inscribed angle? All right, so let me move D. It looks like they stay the same. I mean, it's going to be 36.82 no matter where I put it on the circle. Put it right there, it's 36.82. Put it over here, it's 36.82. 36.82, 36.82, 36.82. Nothing changes. The inscribed angle remains half of its central angle. Alright, so it doesn't change. Alright, cool. Question 6. Now move points B and C so that BC form a diameter. Oh, okay. So BC forms a diameter. That means I gotta have it exactly on 180. That's gonna be easier said than done. Not sure if I can get it exactly on 180. I'm looking right here, you guys. I'm trying to get that to 180 for it to be a diameter. I don't know if that's going to happen. I can get it close. There's 180.13. 180.4529. There's 1, 2. I don't know if I can get it in a diameter. What's the measure of the central angle and the inscribed? Oh, okay. Well, there you go. It's going to be 180 and then half of that's 90. The central angle will be 180 degrees and the inscribed angle will be half, which is 90 degrees. Okay, question 7. Finally, select point D and move it around the circumference of circle A. What type of polygon is formed by the line segments joining A, B, and C? Oh, okay, I get what they're going. So this is a right triangle is what they're going with that. It's a right triangle. Right triangle. It's a right triangle because technically this should be 90 degrees. And no matter where I move it, it's going to stay 90. I just couldn't get this perfectly on 180. So that's a right triangle, you guys. That's a right triangle. All right. So regardless, it is a right triangle. Cool. Oh, self-eval. All right. So basically, you need to take away that an inscribed angle is half of its central angle. That's the big key here. So I'm going to submit that.